Okay, so it's time to take a quiz over what we've learned. So we have question 1. How is the magnetic force similar to the gravitational and the electrical forces, and how is it different? So in the case of gravity, you had a gravitational field, and then in the case of electricity, you had the electric field. And then in the case of magnetism, you had the magnetic field. So all three of the forces involve fields. So you have gravitational force, gravitational field, electrical force, electrical field, magnetic force, magnetic field. Now what's different is the direction that particles go in. So that mass in a gravitational field is going to be pulled down, and then charge in the electric field is going to be pulled down if it's a positive charge. And then electricity and magnetism are similar in that they both involve electric charge, but they are going to be different in that the charge has to be moving, and then as it's moving, it makes a force that is perpendicular to both of them. So the directions of the force is completely different than electricity or gravity. Question number 2. Draw the magnetic field of a straight wire. So if you have a straight wire that's carrying current I, and this would be positive current that is going up, then you take your right hand, the thumb points in the direction of the current, and then the fingers are going to curl around it, so that you need to have a circle that goes around and then behind, and then you'd have another circle that goes around and then behind, and then down here just repeat it. So you have another circle that goes around and behind, and another circle that goes around and behind. So you have an infinite number of circles that are going around the wire, and you have an infinite number of circles within circles. Question number 3. A 3 Coulomb charge traveling at 2 meters per second feels a force of 24 newtons when placed into a magnetic field. What was the magnitude of the magnetic field? So what variables are you given in the problem? It says a 3 Coulomb charge. So Coulomb is a unit of charge, and the charge was the letter Q. Traveling at 2 meters per second. So meters per second is a unit of speed. So the unit or the letter for speed is V. And then feels a force of 24 newtons, and the letter that stands for force is F. And then what variable are you looking for? It says what was the magnitude of the field. So what we are looking for is going to be the magnetic field. Okay, then the next thing says what equation connects the variables. So that would be the force of magnetism is going to be equal to Q, V, and then B. So let's plug in our numbers, and Q was 3 multiplied by the V, which was 2, multiplied by the B we don't know, so let's put in a B. But we do know that the F, the force of magnetism, was equal to 24. All right, so we're going to take 24 divided by 3, so that's going to be 8, and then take 8 divided by 2, that's going to be 4. So that meant that the magnetic field was equal to 4. And then what unit? The official metric unit for magnetism is the Tesla. So put a T on the end of it. Explain how the right-hand rule is used to determine the directions of magnetic variables. So, right-hand rule, okay, so that the first finger is going to be the direction a single particle is going in, or it could be the direction of the current if it's a wire. Okay, then this finger here, so this finger here, that's going to be the direction of B, the magnetic field, and then the thumb is going to be the direction of the magnetic force. And so we're always going to assume that each one of them is perpendicular, but it turns out that these two can have different angles, but the thumb is always perpendicular to the two of them. Number 5, why do only certain atoms create magnetism? So we said the most important thing that creates the magnetism in an atom was the blank of its blanks, the spin of its electrons. And so if you have only one electron, one outer electron, then it will produce a teeny tiny little magnet. But if you've got two valence electrons, then what will happen is that they will cancel each other, so then you don't have any magnetism. If you've got three, well, then it does this, and so again you're back to having just one that has any net magnetism. But what did we say was important about iron? Iron had 4 of them that all pointed in the same direction, and so it has a very strong magnetic field. An iron atom has a very strong magnetic field. And so it has to do with the spin of the electrons that are inside of it. How can a magnet be created by using electricity? All right, so that was an electromagnet. And so the best way to make an electromagnet is to take your wire and bend it into a coil and then attach it to a battery, so then it creates a magnetic field. Now you can just do it with a straight wire, but the magnetic force, the magnetic field that's created is not going to be as strong. So by turning it into a coil, it concentrates the magnetic field. So that's the best way to make an electromagnet. So there is our lesson about magnetism. And so we've now talked about electricity, and we've now talked about magnetism. So in our final lecture about electricity and magnetism, we're going to put the two of them together, and we're going to call it electromagnetism. So I will see you then.